First question is we need to solve integral 1 to infinity 1 by x raised to 4 dx. So this will be equal to integral 1 to infinity. So this will be x raised to minus 4 dx. So the integral will be x raised to minus 4 plus 1 by minus 4 plus 1 from 1 to infinity. So this will be 1 by minus 3 x raised to 3 from 1 to infinity. So at infinity we know that 1 by infinity will be 0 minus at 1 we will get minus 1 by 3. So therefore the value of integral will be 1 by 3. Second one we need to solve integral 1 to infinity 1 by x dx. The antiderivative of 1 by x will be log x. So we'll apply the limit from 1 to infinity. So this will be log infinity minus log 1. So log infinity, log 1 is 0 and log infinity will be infinity. So therefore integral value will be equal to infinity. Next one we need to solve integral 10 to infinity 1 by x log x dx. For this we'll use a substitution u equal to log x. So du will be 1 by x dx, and we know that x varies from 10 to infinity. So u will vary from, so when x is equal to 10 u will be log 10, and as x goes to infinity log x will also go to infinity. So the limit will be from u varying from log 10 to infinity. So this will be integral log 10 to infinity, and using the substitution we'll get du by u. So this will be equal to, again integral of 1 by u will be log u, again from limit will be from log 10 to infinity. So we'll get log infinity minus log of log 10. So this will be infinity minus some finite number. So the value will be equal to infinity. So that will be the integral value. And next problem we have integral 0 to infinity e power minus 5x dx. The integral of e power minus 5x will be e power minus 5x by minus 5. Now applying the limit from 0 to infinity. So here we'll get e power minus infinity minus e power minus 0 by minus 5, and e power minus infinity will be 0 minus, we know that e power 0 is 1, so this will be 1 by minus 5. So the value of integral will be equal to 1 by 5. And next question we have integral 0 to infinity x e power minus x square dx, and here we will use a substitution u equal to x square. So du will be equal to 2x dx, and x varies from 0 to infinity. So x square u will be equal to x square. So u will also vary from 0 to infinity. So we will get the integral as 0 to infinity e power minus u, and x dx will be equal to du by 2. Now upon integrating we will get 1 by 2. Integral of e power minus u will be e power minus u by minus 1 from 0 to infinity. So that will be minus 1 by 2 at infinity. So we have e power minus infinity minus e power minus 0. So that will be minus 1 by 2. E power minus infinity goes to 0 and e power minus 0 will be 1. So the value of integral will be 1 by 2. And next question, we need to evaluate integral 0 to infinity x e raised to minus 5x dx. So for this we will use the integration by parts. So value of integral will be first function into integral of the second. So integral of the second will be e power minus 5x by minus 5 from 0 to infinity minus integral of derivative of the first. Derivative of x will be 1 into integral of the second. So integral of second function will be e power minus 5x by minus 5 dx. Now applying the limit in the first term. So in the first term we have e power minus infinity. So this will be infinity into e power infinity. So the first term becomes 0. Now at 0, x is equal to 0. So when we apply the limit for first term, we will be getting 0 at both the ends. Then minus, again minus 1 by 5 will come out. So we will have integral 0 to infinity e power minus 5x dx. So this will be 1 by 5. Now integral of e power minus 5x will be e power minus 5x by minus 5 from 0 to infinity. So that will be minus 1 by 25 e power minus infinity minus e power minus 0. So that will be minus 1 by 25 into 0 minus 1. So the value will be 1 by 25. So value of integral will be 1 by 25. So here we will be using integration by parts in this problem. So that is this way. So if you have a product, so if you have integral uv dx, then value of integral will be first function into integral of the second minus integral of derivative of the first into integral of the second. So we need to find this integral and then u dash into this function. So we need to integrate that function. So this is what we'll be doing in integration by parts. And next, 7th question. So we need to evaluate integral minus infinity to infinity 1 by 1 plus x square dx. And as we can see, the integrand is 1 by 1 plus x square. So this is an even function. So when we take f of x is equal to f of minus x. So this is an even function. So the integral will be equal to 2 times integral 0 to infinity 1 by 1 plus x square dx, and integral of 1 by 1 plus x square x will be 1 by 1 plus x square is tan inverse of x. Now applying the limit from 0 to infinity, we will get 2 times, and now tan inverse of infinity minus tan inverse of 0 will come, and tan inverse of infinity will be pi by 2 and tan inverse of 0 is 0. So we will be getting pi as the integral value. And number 8, we need to evaluate integral 0 to 1 by x dx. So integral of 1 by x will be log x. We need to apply the limit from 0 to 1. Now we know that this will be, so applying the limits, this will be log 1 minus log 0. So log 1 is 0, 0 minus log 0, but log 0 is not defined, so which is not defined. So this integral does not exist. So since log 0 is not defined, the integral does not exist. Next one, integral 0 to 1 by root x dx will be, so this will be integral 0 to 1 x raised to minus 1 by 2 dx. Upon integrating, we will get x raised to minus 1 by 2 plus 1 by minus 1 by 2 plus 1 from 0 to 1. So that is x raised to 1 by 2 by 1 by 2 from 0 to 1. So applying the limits, 1 raised to 1 by 2 is 1, and at 0 we'll get 0 by 1 by 2. So 1 by 1 by 2 will be equal to 2. So value of the integral will be equal to 2. And question number 10, we need to evaluate integral 0 to 1 log x dx. So for evaluating this integral, again we'll use the integration by parts. So for integration by parts, we need product of two functions. So we'll take one function as log x and the second one as 1. Okay. So this will be u and 1 will be equal to v. So by integration by parts, integral uv dx will be first function u into, so first function into integral of the second. So integral of 1 will be x. So applying the limits from 0 to 1 minus integral of derivative of the first one. So derivative of log x will be 1 by x into integral of the second. So we need integral of 1. Integral of 1 will be, so we need this, then we need to take the total integral. Okay. So at 1 we know that log 1 will be equal to 0, and at 0 x will be 0, and minus integral 0 to 1, so we will get 1 by x, and integral 1 dx will be x. So this will be minus integral 0 to 1 dx. So that will be minus x from 0 to 1. So the value will be equal to minus 1. And question number 11, we need to evaluate integral minus 1 to 4 x by x square minus 9 dx. And here we will use a substitution u equal to x square minus 9. So du will be 2x dx, and x varies from minus 1 to 4. So u will vary from minus 1 whole square minus 9 will be minus 8 to at 4. So we'll get u as 16 minus 9, so which is equal to 7. So this will be equal to integral minus 8 to 7. So x dx will be du by 2, then x square minus 9 is u, so we'll get 1 by 2, and integral of 1 by u will be log u from minus 8 to 7. So since integral of 1 by u will be actually log mod u, so we need to put mod u here since we have a negative value appearing here. Okay. So we will be getting 1 by 2 log mod 7 minus log mod of minus 8. So that will be equal to 1 by 2 log 7 minus modulus of minus 8 will be equal to log 8. So this will be the value of the integral. And question number 12, we need to evaluate integral 0 to 25 1 by root x dx. So that will be integral 0 to 25 x raised to minus 1 by 2 dx. So we will get x raised to minus 1 by 2 plus 1 by minus 1 by 2 plus 1 from 0 to 25. So that will be x raised to 1 by 2 by 1 by 2 from 0 to 25. So we will get 25 raised to 1 by 2 minus at x equal to 0. We will be getting 0 by 1 by 2. So that will be 5 by 1 by 2, which is equal to 10. So integral value will be equal to 10.